My name is HAZRIQ HAKIM in JULAILI, and me representing my group. Today I'm going to show you my project. So my project is a hot box for food storage. So as you can see now, this is the solar panel. Right. After the solar panel, connect with the heatsink or the Peltier fans. This is the cold side of the Peltier or cold side of the heatsink, and this is the Peltier. Alright, let's move to the inside of the hot box. Now, as you can see, this is the insulation. Behind this insulation, we have the coconut husk for the first layer, and the second layer is the aluminium foil. And now, inside the heatsink, this is the hot side heatsink, and this is the fan for blow the hot air to distribute the hot air inside the hot box. So that's all for the introduction. Now we proceed to the testing and commissioning. Alright, after we have done our testing and commissioning, we have recorded the peak temperature for our hot box product, which located at almost 60, which at 58 degrees Celsius. So the ideal temperature for the food is 55 to 60 degrees Celsius to keep the food hot, the warmness and the freshness. That's all from me. So me and my group decide to testing and commissioning our product on a fully sunny day, because we want to get the highest temperature or the potential highest temperature for this product. That's all.
Assalamualaikum. My name is MOHSIN. Today I'm going to conduct our test run on our project. So we are going to take the initial temperature without any power peltier on our project. So we're going to take a look at the temperature without any power from peltier or power bank. So initial temperature is 33.4 degrees Celsius. So this is our initial temperature. So time is about 10 o'clock. So after 20 minutes we're going to take another reading. So that's all. So this about 10:24. We're going to take data of the temperature after 20 minutes of operating with the peltier. Okay, after 20 minutes of operating, the peltier generates 39.4 degrees Celsius. So we're going to take another 20 minutes to take another temperature up to 80 minutes of operating for this project. So another 20 minutes pass. Now it's 10:46 o'clock. So the temperature is 42.8 degrees Celsius after 40 minutes of operating. So now it's 11:05 o'clock in the morning. So that's total about 60 minutes of our project for lava box been operating with power peltier. So we take a look at the current temperature. Now the power is 43.4 degrees Celsius. So we're going to take another 20 minutes to confirm the peak temperature that our peltier can generate with the solar power and power bank. So stay tuned. So another 20 minutes pass. That's total of 80 minutes, or 1 hour and 20 minutes. Our project has operate. So we are going to check the peak temperature that our peltier generated. So the peak temperature is 45.6 degrees Celsius after 1 hour and 20 minutes of operating. So after we get the peak temperature for an hour and 20 minutes, we are going to cut off the power supply and solar power from our lava box. Then we are going to take the data after 20 minutes of the lava box do not powered with any power supply to see the temperature dissipated over 20 minutes up to 1 hour and 20 minutes. So the peak temperature is 45.6. So for the next 20 minutes we are going to see how much the heat we lost to the surrounding after it's not powered by the budget and any power supply. So we already cut off the power supply from our project. There is no power bank. So now it's about 11:29 o'clock. So after 20 minutes is 11:49. We're going to check the temperature dissipated after 20 minutes. Alright, stay tuned. So another 20 minutes fast after we cut off the power supply from our box. We're going to check the temperature. So the power or the temperature decreased to 41 degrees Celsius. Okay, so we take another 20 minutes. So now is 12 o'clock. It's about 40 minutes. Our project that's not powered with any power supply. So we're going to check the temperature. Now it's about 35.2. Yes, 35.2 degrees Celsius after 40 minutes of not powered by any power supply. So now it's 12:31 am. So we're going to check the temperature after 60 minutes of the lava box not powered with any power supply. 37.4. Yes, 37.4. So we're going to take a last reading of temperature after 80 minutes of inactive power supply for our lava box project. So 80 minutes have passed. Temperature remain is 42.5 degrees Celsius after 80 minutes. The last temperature remain in the box. Thank you and Assalamualaikum. This is our end of our test run.
Assalamualaikum warahmatullahi wabarakatuh and very good day to our lecturer Dr. Muhammad Zulkarnain. My name is ZULFIKRI bin MAZLAN. So I will start the presentation about BMMH2413 HVAC design project. So our supervisor is TS Muhammad Noor bin Osman, and our group members we have HAZRIQ bin JULAILI, Smail, HARISHWAR anak lelaki MOHAN, and me ADIE ZULFIKRI bin MAZLAN, and also MUHSIN AMILI bin NOOR. So this is our organizational chart. So first on the top is HAZRIQ JULAILI as position PD to check project progress and monitor our team. And then on the left, HARISHWAR anak lelaki MOHAN is positioned as PM, responsible for planning and leading project. Right is me, positioned as MRE, recommend a suitable system use. And down and left, Haris anak Smail, positioned as DE, study and develop idea, sketch design. And last at the right, MUHSIN AMILI bin NOOR, positioned as CFO, executing the financial strategy. So this is our time plan. So we start the program from 15 April 2022, and this is our average plan from start and in the middle. Chapter 1, Introduction. Food delivery services. Expecting to keep delivered food hot and fresh. Food delivery bags should be of good quality. Without a solid source of heat, the food will eventually get cold for some time. The globe is currently leaning toward renewable energy resources as a source of energy. We have used source to have a clean energy efficiency and using friendly environmental materials such as coconut husk as its heat insulator, which will give an extra insulation to aluminium to sustain the temperature. objective to create a heating box to keep the food warm during delivery, to use solar powered energy as its source of energy, and to use green technology and eco-friendly item as its main part. The scope of this project is focused on helping food delivery services to maintain their quality of food in terms of warmness and freshness. So about the problem statement. First, procedures of designing a food delivery box that can maintain food warm. Second, delivery box purposely designed to insulate the heat to prevent heat escape. We believe that our project is the first step to developing more products related to HVAC. We applied an eco-friendly factor to our product and finding a feasible solution within our problem space has the potential to develop HVAC fits to a greater height. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Smail and MOHSIN. Today I'm going to introduce our team member and the other scope. So I'm going to introduce HAZRIQ HAKIM BMMH2413. He's going to monitor the team progression and check the project progress. And our next member is HARISHWAR and HAKIM. He's in charge of leading the project and managing the report. And third, our member is ADIE ZULFIKRI bin MAZLAN. He is responsible for material selection and draw the lava box names in SolidWorks. And the fourth member is Smail, sketch and develop ideas for the lava box project. And lastly, me, AMILI, I'm going to prepare the financial statement and reports and also documentation. And the next slide is flowchart or flowchart design product. First, for this project, we are going to approach by generating the idea for the project and creating and choosing the best idea for our project. So then we took our idea and suggested it to our supervisor. If it's rejected, we're going to generate a new idea for the project. In other words, if it's accepted, we're going to buy all the required items for the project and create a sketch based on the project. Then we finalize the project based on the sketch diagram. For the last procedure, we're going to testing and commencing the project to test its effectiveness or efficiency. Our next slide is project overview to assess our project in terms of history and the technology have been used before our time. So the discovery around 3500 BCE, civilization began in Mesopotamia. People could manipulate food to preserve it through sun drying, fermentation, freezing inside the snow, or cooking by fire was a key factor in nomads settling up. Many techniques such as thermal treatment, dry, chilling, extract, mixture, and the utilization of preservative have been developed throughout human history. This perspective document gives an overview of the major heating up unit operation in the food industry. Physical process, on either hand, has a variety of intensities, and the amount of energy used depends on the type of food, target microorganism, storage temperature, packaging type, and intended shelf life. There are still considerable obstacles for the food industry to design procedure in the best condition for the quality of food and with the least amount of environmental effect, and a new thermal and non-thermal technology has been invented to help. And in 1832, when a French physicist named Jean-Charles Athanas Peltier found that an electrical current could affecting heating or cooling at the junction of two dissimilar metals. In 1838, Lenz proved that heat could be removed from a junction to a freeze water into ice. Depending on the direction of current flow, the electric current influences how much heat is absorbed or produced at the connection. In heating cooling in a single system, a voltage is placed across a Peltier element. One side is cool and the other side is simultaneously heat up. Peltier elements are probably the best known industrial application of the Peltier's effect. These are connected in series. The contamination with the extraneous atom causes a difference in the conductivity of the two materials. One side of the Peltier element becomes cool as an energy is extracted from it by passing an electrical current through it, while the other side releases the heat extracted from the cold side into the environment. A Peltier device is used in a temperature-controlled food storage unit to control temperature of food placed in a thermal conductive container or basin. A fan blows through a duct and overheat sinks that is thermal linked to one side of the Peltier device. The airflow via the air duct and overheat sink is controlled by hand-operated damper, which regulates the heat exchange between the Peltier device and the ambient air. And lastly, from me is the idea generated for this project. First, the main idea is a food delivery. The purpose is to keep the food warm, use a good material, and using the electricity to generate the system, and to meet the customer requirement, especially the food grab or food delivery service. That's all for me. Thank you and assalamualaikum.
A very good day, sir. My name is HARISHWAR MOHAN from BMMH2413. So today I'm going to explain more about our accessories, means our parts, our project parts. As an example, so we took how Peltier and solar panel works. So we wanted to explain about how the Peltier and solar panel works for this project. A thermoelectric device creates a voltage when there is a different temperature on each side. So for Peltier, there's got two sides. The Peltier effect can be used to create a compact refrigerator with no circulating fluid or moving parts. The voltage is applied across joint conductors to create an electric current. The main application of the Peltier effect is cooling. So most probably the consumer will use for both cooling and also heating. So Peltier effect also can be used for heating or control of temperature, as I said before. For solar panel, a solar cell is defined as an electrical device that converts light energy into electrical energy through the photovoltaic effect. It is also defined as a device whose electrical characteristics such as current, voltage, or resistance vary when exposed to light. Photovoltaic effect is a process that generates a voltage or electric current when it is exposed to sunlight. So mostly the solar panel can be used when there's got a sunlight. The photovoltaic effect was firstly discovered in 1839 by Edmund Becquerel. So our next slide will be about the cost. So this is our cost for our product making. So the first one, storage box 26 ringgit, heatsink Peltier around 48.9 cents, 3-core wire 2 ringgit 20 cents, 20 volt solar panel. There's no price because it's given by our supervisor. Aluminium foil is 7 ringgit, coconut husk is 13.50, wire connector is 2 ringgit 20 cents, solar controller 20 ampere is 19 ringgit. So the total will be 118.49 cents. So this is our total cost which we spent for our product. So about bill of material, this is our material which we used for make a whole product. First one, 25 liter storage box. The second one, heatsink Peltier. To connect the wires, we used to connect the connections, we used 3-core wire. For the main supply, we used 20 volt solar panel, aluminium foil, solar controller, coconut husk, and also wire connector. So this is the sketch which we showed on the first meeting. So there's no any changes in the drawing. We just stick to the drawing, the previous drawing. Assembly view of device, the complete view. This one's the complete view. So on my left, on top is front view. On my right, on side view, the top view, and also insider view, the view of inside, how it will be like. So drawing with BOM. So this is the measurement and the whole measurement, and also the reading. So design with dimensions. Here or design with dimensions for all sides, from top side and also back. And as a process in terms of safety, environmental, and sustainability factors. So we're going to discuss about safety on solar aspect. Solar PV system includes several components that conduct electricity as sample, solar array, the inverter, and other essential parts. When some parts live with electricity by the sun, they can cause serious injuries to electric shock or arc flash. Some of the ways you can keep users safe include covering the solar array with an opaque sheet to block the sun's light, treating wiring coming from a solar panel PV system with the same caution as a utility power line. That means assuming all wires are live, locking out power on system that can be locked out, check all circuits you are working on at points where the equipment or circuit can be energized. That's all from me, sir. Thank you.
Assalamualaikum and my name is HAZRIQ bin JULAILI, and today I will continue the presentation on the BMMH design project, configuration design project. So today I would like to talk about environmental. So fossil fuel generate harmful gases like methane and carbon dioxide, which reduce the air quality. Solar energy dramatically reduce carbon emission in the air you breathe. The burning of fossil fuel increases the presence of greenhouse gases like carbon dioxide and methane. The consequences increase in the global temperature result in the melting of glacier and rising sea level. Generating electricity from solar panel does not produce any greenhouse gases, therefore helps to slow the climate change. The sustainability. Okay. The sun releases enough energy on Earth each second to provide the entire human for every 2 hours. So energy is essential for human, and solar power is the ultimate energy house source. Sun as a solar energy source has many advantages. It is sufficient, virtually infinite, and provide equal access to all users. With all the advanced technology in the solar panel and how electric companies have increased price, it is a safe bet to say that going solar today. Right. So let's proceed with the chapter 2, which are the discussion on the structural analysis on von Mises displacement, deformation, and factor of safety. Right. So as you can see now, the von Mises stress. Von Mises stress, we got a maximum in our project for the von Mises stress is 6.6 exponent power of 2, and the minimum stress is 1.133 exponent of 0.2. Right, so as you can see on the right hand side is a thermal analysis. So we undergo the thermal analysis on our project. So we get the minimum temperature for our project is 30 degrees Celsius, and the maximum that our project can trap the heat is 68 degrees Celsius according to the simulation. For the displacement, we got the minimum of 1.320 exponent negative of 11, and the maximum is 2.659 exponent negative power of 7. So the deformation, same just like the displacement. So the deformation, we got 1.080 exponent of negative 30, and the maximum we got a 3.422 exponent of negative 6 for our deformation. So this is the body, and most of the body is a minimum section, so the deformation doesn't affect the design. So next is a factor of safety. Right, factor of safety, the simulation apps can't analyze the factor of safety or can't define, because the item we use ABS plastic, so the factor of safety is very low, so they can't define our factor of safety. So next is a discussion on techniques to improve design failure during analysis. Alright, so to succeed in the product development market, companies and swiftly and precise meet customer expectation while producing goods and sufficient perform intended duties with the fewest possible defect. We found a few failures in the earlier stage we counted during testing and analysis. First, we found the product durability is questionable as we use ABC plastic box. We could switch a better material such as EPP insulation of the main body and EPP insulation heating application is made of expanded propylene due to half shell system. So the first we found that the product we use questionable is ABC plastic box. So we use the ABC plastic box because it's light and cheap material. We can use another product, another material such as lightweight metals, but it costs more to produce one prototype of the design. So we just go for a low budget, which and easy to purchase. Anywhere can purchase, right? So the EPP insulation is heating application is made expanded propylene due to half shell system. So expanded propylene has a very useful features for a several field shape memory indeed. It is a major asset as it keeps its structure without breaking. As you can see the technical data here on the right hand side, maximum operating temperature is up to 110 Celsius. The thermal conductivity is 0.035. The fire properties is B2 according to serial of DIN 4102. the material is expanded properly, and the specific gravity is 40 kilogram meter square. So last but not least from me is secondly, we found our product is lacking of power supply because a 12 volt solar panel could not generate enough power for the peltier which we expected. So this is a failure during analysis or testing commissioning. So to counter this problem, we found a solution which power supply with a solar power bank, which means the power bank keep the energy inside the power bank, and we charge the power bank using the solar panel. So the solar power bank will reduce the overall weight, which will be the convenient for our customer. So why we use the solar power bank as our alternative, because if you use the battery, it could add more weight to the customer. So it would not be suitable and not comfortable or convenient. So the solar power bank is also capable to storing energy, can operate at night. So there is no presence of sunlight. If there is no presence of the sunlight, the solar power bank also can be power both peltier and solar panel. Solar power bank are affordable, eco-friendly, cost-saving, and reliable source power supply for your gadget. Right. So the alternative, instead of fully supply from the solar panel, we use the solar power bank also. Solar power bank is also known as a portable power pack. Right. That's all from me. Thank you. And let me hand the presentation to my group members. That's all from me.
Hello, my name is Smail, and I'm from BMMH Station 2, Bandung, and I'm representing for the site of the BMMH2413 Hvac design project. And as you can see from this slide, I'm representing the idea to improve the device. To improve our device, our team consider 4 options to improve our design, and this is change the box material, change the solar panel. To change the box material, the first material for our box is ABS plastic, and our team planning to change the box material to aluminium because aluminium will conduct more heat due to its properties. Then we proceed to change solar panel. By changing solar panel, we think our team plan to increase the solar panel numbers. By increasing the solar panel numbers, we increase the power to the peltier, because the peltier, the more power to the peltier, the more heating is the peltier will give up. Then proceed to the next slide, to the next option. By swapping the different insulation. By changing the different insulation, for now our team using the coconut husk as our friendly insulation. But if our team change the insulation to different material, the result of the temperature of our device may be changed, consider it higher or lower. And so the next option is by adding more peltier. By adding more peltier, we're leading to more heating. But with it adding more peltier, we increase the requirement of the power usage. That will affect the voltage for the overall design. Thus, our team consider by adding more peltier, our team needs also to change the number of solar panel our solar panel are using. And that's all for the slide of the idea to improve the device. We proceed for the next slide. Now, this is our conclusion based on our finding. And for the thing, to improve the device, we can select a different material for the box of the design use. For example, the current material for the design is ABS plastic, which can be a good heat conductor for heating purpose. Other cases, we can change the material to aluminum, which can generate more faster than the ABS plastic box. The ABS The aluminum has a good conductor insulation that will boost the speed of heat step-up for up the peltier twice faster than ABS plastic. But the downside of using aluminum, because aluminum are easily to bend and can leave a mark when applied to pressure. And for the next point, when aluminum is noisy, aluminum is easy compared to ABS plastic because aluminum is metal. The other way to improve the device is to upgrade the solar panel to a new model that can give a higher power output. Then also, by increasing the number of petals of the design is one of the best option to improve the design, such as increase the number of petals installed on the project, because the more petals inside, the more efficiency of the heating. And proceed and proceed to the next slide. On the result, experimental result, that is testing and commissioning of our product design. For the result of temperature rising, there is petal is switched on or connected to a power source. On the first minutes of temperature, the temperature is the normal temperature of our adder is 32.1. Then when we proceed to 20 minutes of the time taken, the interval of the 20 minutes of our time taken of the data. For the first 30 minutes, the temperature of our design is 39.7. And then we proceeding to the 40 minutes of the interval, the temperature is 45.0. Then on the 60, the temperature are rising to the 49.7, and finally on the 80 minutes of our testing, the temperature increased to 51.2. Since the temperature increased to 51.2, according to the Minnesota maintained food at 185 Fahrenheit or equal to 57.2 Celsius, is enough to maintain a hot food in a box. The hot box almost reached the desired temperature for the maintaining food. However, there are some factors why the temperature reach its desired target, such as that they get enough sunlight due to the cloudy days. And we proceed to the result of temperature drop to the hot side. That means the temperature as the petal are switched off or disconnect from the power source. On the first 0 minutes, our temperature is still maintained 51.2. Then for the next 30 minutes, the temperature dropped to 45.2, and for the 40 minutes, the temperature dropped to 42.4. Then for the 60 minutes, the temperature dropped to 39.2, and finally for the 80 minutes of the drop, the temperature are 38.0. This means the temperature in the box are slowly decreasing. This means it's good because it still can maintain hot temperature for the food, even it's disconnected from the power source. And proceed for the next slide. On the conclusion, based on the conclusion, the hot box will be used in the future for the food delivery service as food product. As the product main function is to maintain the temperature of the food for its warmth and freshness. The globe is currently leaning toward renewable energy source such as the source of energy. The optimum approach will be to employ a renewable energy source to deliver energy to these homes without the need for an expensive electrical grid connection. The grid technology design is environmental friendly to the user without air pollution problems. The solution is a new idea by using the coconut husk as a cheap insulator and easy to get, and this hot box is portable and can be placed in most places to make a food delivery easier. The prediction in the future is the time taken to reach its peak temperature is faster compared to current product by using advanced solar panel or high quality insulation to prevent the heat leakage. And finally, humans should optimize the sunlight as a renewable energy and transform the heat from the sunlight to electrical energy for daily usage as the world is getting critical of supply of fossil fuels, coal and crude oil to generate electricity to the consumer nowadays. And that's all for our conclusion. Thank you.